When you think about routers, what's the first thing that comes to mind? Probably a box with blinking lights, right? A piece of hardware. But what if I told you that the real magic, the brain behind that box, is its operating system? Just like your computer runs Windows or macOS and your phone runs Android or iOS, routers have their own specialized operating systems. These aren't designed for flashy graphics or running apps. They're built for one thing: managing network traffic with incredible speed and reliability. In this video, we're diving deep into the world of router operating systems, exploring everything from the industry giants to the flexible open-source options. This is the software that truly runs the internet. So, what exactly is a router operating system? At its core, it's the software that controls everything the router does. It's responsible for making crucial routing decisions, figuring out the best path to send your data across the internet. It handles the actual process of packet forwarding, moving data from one network to another at lightning speed. It also manages all the security features, protecting your network from unauthorized access. And it supports all the essential network protocols that allow devices to communicate. Unlike a desktop OS, a router OS is optimized for raw performance, stability, and uptime. It's designed to run 24/7 for years without a single reboot. The user interface is often a command line, not a graphical one, because network engineers need precision and power, not fancy icons. It's the silent, unsung hero of network infrastructure. Let's start with the most famous name in the game, Cisco. If you've ever touched a piece of networking gear, you've probably heard of it. Cisco IOS, which stands for Internetwork Operating System, has been the dominant force for decades. You'll find it powering routers in enterprise networks, massive service provider backbones, and huge data centers all over the world. What makes it so popular? First, its powerful command line interface, or CLI, gives network engineers granular control over every aspect of the router. Second, it supports a huge range of routing protocols, from OSPF and EIGRP for internal networks to BGP, the protocol that runs the entire internet. And most importantly, it's known for its legendary reliability. For a long time, learning Cisco IOS was a rite of passage for any network professional, and it truly set the standard for what a router operating system should be. But as networks grew bigger and more complex, the original Cisco IOS started to show its age. To meet the demands of the modern internet, Cisco developed two new, more advanced operating systems, iOS XE and iOS XR. Think of Cisco iOS XE as the evolution of the classic iOS for modern enterprise and campus networks. It keeps the familiar iOS command line feel, but runs on a modular, Linux-based core. This makes it more stable and allows for cool features like running applications directly on the router. Then there's Cisco iOS XR, which is a completely different beast. This is a carrier-grade operating system designed for the largest service providers on the planet. It's built for massive scalability and high availability. Its key feature is fault isolation, meaning if one part of the software has a problem, it doesn't bring down the entire router. These systems were engineered from the ground up to handle the massive, always-on networks of today. Of course, Cisco isn't the only major player. Another giant in the high-end networking space is Juniper Networks, and their operating system is called Junos OS. Junos has a very loyal following among network engineers, especially in large ISP and data center environments, and for good reason. One of its key strengths is its clean, hierarchical configuration structure, which many find more logical and easier to manage than other systems. A standout feature is its commit-based configuration model. You can make a bunch of changes, review them, and then apply them all at once with a single commit command. If you make a mistake, you can easily roll back to a previous configuration. Junos is also praised for its powerful automation capabilities and rock-solid stability, making it a top choice for mission-critical networks where downtime is not an option. Now, let's move from the high-end enterprise world to something more accessible. Meet MikroTik RouterOS. If you've ever set up a network for a small business, a wireless ISP, or even a sophisticated home lab, you've likely come across it. The biggest draw for RouterOS is its incredible value. It offers a set of features that can rival expensive enterprise gear, but at a fraction of the cost. You can run it on MikroTik's own affordable hardware or even install it on a standard PC to turn it into a powerful router. Despite its low price point, RouterOS is packed with advanced routing features, robust firewall capabilities, and powerful wireless management tools. This combination of flexibility, power, and affordability has made it a favorite among smaller ISPs, network training environments, and tech enthusiasts who love to tinker and build custom solutions. Another major global player in the networking space, particularly in the telecommunications sector, is Huawei. Their network devices are powered by an operating system called VRP, which stands for Versatile Routing Platform. As the name suggests, VRP is designed to be a flexible and powerful platform that scales from small enterprise routers all the way up to massive core routers used in national telecom networks. VRP is known for its high performance and comprehensive feature set, built to meet the rigorous demands of telecom carriers. It supports a vast array of protocols and technologies required for building and managing large-scale infrastructure. While you might not see it as often in smaller North American enterprise networks, VRP is a dominant force in many parts of the world, especially in Asia, Europe, and Africa, powering a significant portion of the global mobile and internet infrastructure. So far, we've talked about proprietary systems from big companies. But just like with computer operating systems, there's a vibrant world of open-source router software. These systems are typically based on Linux or BSD and offer incredible flexibility and customization. One of the most popular is OpenWrt. It's a Linux-based distribution that you can install on a wide variety of off-the-shelf consumer routers, transforming a basic home device into a powerful, feature-rich networking tool. Then there's VOS, a fork of the original Viata, which is a full-featured network OS designed to run on standard hardware or virtual machines. It provides enterprise-level routing capabilities with a command-line interface that will feel familiar to many network engineers. And we can't forget Pheasants, which started as a firewall but has evolved into a powerful routing platform as well. These open-source options are perfect for labs, custom projects, and anyone who wants total control over their network. This brings us to an important shift happening in the industry. The line between a router OS and a network OS is blurring. Traditionally, you configured a router box by box. But today, networking is becoming software-driven. Modern network operating systems are being built with automation and programmability at their core. Instead of just a command-line interface, they now offer APIS application programming interfaces that allow you to control and manage the network with code. This is the foundation of software-defined networking, or SDN, where a central controller can manage an entire fleet of routers and switches automatically. Many platforms are also integrating with cloud management dashboards, allowing you to monitor and configure your global network from a single web interface. The future of networking isn't about logging into individual devices. It's about managing the network as one cohesive, programmable system. So, as we've seen, a router is so much more than just a piece of hardware. It's an intelligent system powered by a highly specialized operating system that's been finely tuned for performance, stability, and control. From the industry standard Cisco IOS to the flexible open-source OpenWrt, each platform has its own strengths and is designed for a specific purpose. Understanding these different router operating systems is no longer just a niche skill for network engineers. As our world becomes more connected and infrastructure moves to the cloud, knowing how the underlying network operates is a crucial skill for anyone in technology, from system administrators to DevOps engineers and cloud architects. The software running these boxes is what truly powers our digital world. Thanks so much for watching. If you found this video helpful, be sure to hit that like button and subscribe for more deep dives into the technology that runs our world. Let me know in the comments which router OS you use or are most interested in. See you in the next one.